Hello and welcome to another video from our BeamTool tutorial video series. In this video, we want to go over another example of FMC workspace in BeamTool. Specifically, we want to show how we can use point spread function based quality maps to compare techniques instead of using direct experimental or calibration verification. The example that we want to use to go over this is a design of a phase coherence based inspection for high temperature hydrogen attack. In previous videos, we introduced point spread function simulation, and also we discussed phase coherence imaging and total focusing method imaging techniques that are used for making images based on full matrix capture data. If you haven't had a chance to go over those videos, I recommend that you first go through those videos, and when you are familiar with those concepts, come back to follow this video. So here, a few years back, we had a chance to get access to a sample from Lavender International in Houston that has a verified early stage HTHA damage, which is the stage that are only methane voids and microfissures along grain boundaries before cracking, and these are in the scale of 10 to 50 microns. At a time, we have with us a 5 MHz 64 element probe with pitch 1, which was a near wall probe. And what we did, we put that probe in contact with that piece and used a LL longitudinal modes in contact and to collect the full matrix capture data. Then we used that data to render a phase coherence image-based image, and in that image we saw that we see these indications close to back wall progressing through mid wall, which were exactly correlating with where it was verified that we have these microfissures or voids in the sample. And the conclusion then at that point was made that phase coherence imaging with large aperture probe can have a good chance of detecting this type of geometry in early stage. A few years after that, we were asked to do the similar inspection, but this time on actual vessel in the field. The problem was, obviously, we could not directly use the technique which has been verified, and which was putting a probe in contact. So what we needed to do, we needed to use a wedge. So we needed to put a probe on top of a wedge so that the wedge can be in contact with a vessel surface rather than the probe directly. But the issue was we had no verification that a new technique with a wedge can provide the same level of sensitivity to these early stage voids. We also did not have the same sample in our access that we can recheck a new technique with the wedge and verify that. And also there was no possibility of making a calibration block that can assess these two techniques, because the type of targets that go in the calibration block, such as notches or different type of holes, are not suitable or not representative of this kind of damage. So the idea was that we use BeamTool and we use point spread function simulation to directly compare these two techniques in terms of sensitivity or focal area, and then with the hope that if we design a technique such that its focal area size or sensitivity be similar to a technique which has already been verified, that can be a justification for us to move to a new technique for the actual field inspection. So the point spread function quality maps be basically a bridge between a new technique and an already verified technique to justify using a new technique. And specifically, the focal area map is the criteria that we wanted to use because it was tied into how focused our technique can be. So here we build these two techniques and try to assess them in BeamTool. Intuitively, we try to still stick with the large aperture probe. So we use 60 element 1 millimeter pitch probe. But again, we try to increase our frequency to 7.5, sort of intuitively to compensate for the fact that now we have an intermediate mid layer between the probe and the wedge. So now we go to BeamTool and try to do this comparison. So here, first of all, you can see a 75 millimeter block that is matching with the thickness that we wanted to inspect. The first thing we will do here is to load a probe. We come here to the phase array probe. First, we go to the probe that we already have justification that was verified, which was verified with our sample. So the probe that we used was a near wall probe, 5 megahertz, 64 elements, pitch is 1, but it was in the direct contact mode. So instead of wedge, we go and say contact. And now I put a name for this. It's 5L64 near wall probe. And just make things simple, we try to center this probe. So the active aperture, total aperture of this probe would be 64. So 63 divided by 2, 3.5, 31.5. So that centers probe here. And now what we can do, add a full matrix capture beam set. And for the box, we try to be exactly under the wedge. So we go from minus, let's say, 33 to 33. And for the tips, we go all the way to 75. In terms of the imaging modes, obviously, because we're in contact, we're using L and L, so LL. And at this point, what we can do, we can change this to focal area, and we can, as you saw before, we can run the simulation. So at this point, the point respect function simulation is running, and we get a map that, through that map, we can easily see a distribution of focal area with different with the color palette, and you can see a shadow of point respect function on the background. So let's call this beam set FMC for near wall probe. Now, because we want to compare, we now start to add our second technique that we want to compare. And that will be a technique that we want to actually implement in the field with the wedge. So here, just turn off here we will load 7.5 megahertz 60 element probe, near wall probe, PWZ1. And for the wedge, here we are not going to be contact anymore. We use SPWZ1 0L wedge, which basically has a height of 20 millimeter, and the probe is sitting on that. So we rename this to 7.5L 60 and then 0L technique. And it's again, to be direct comparison, we wanted to center this, so it's 7.5. So we come to minus 5 over 37.5. So now this probe is also centered, and now what we need to do, add another FMC beam set, and on that we try to match exactly the same box, minus 33 to 33, and then for this we go all the way to 75 millimeter. But one thing we need to pay attention now, because we are on the wedge, technically we have option to render also shear modes. So we need to pay attention to that. And here again, we want to directly compare. So we go to longitudinal and longitudinal on receive. So we are on LL mode. And here we switch again to focal area. And instead of render here, we want to ask to compare. So if I say compare, BeamTool asks which beam set we want to compare this beam set to, and that would be the FMC of the near wall probe. So when you click that, BeamTool render focal area maps for both techniques and then plot them in the same color palette with the same min and max range so we can directly compare the two techniques. Okay, so this is now what we start to see as comparison of the focal area map from the top and bottom. And here we can see that our focal area map, the palette that was used, yellow correspond to larger values, so larger focal areas, and close to white is from smaller ones. So what it basically shows us, and the top one is contact and the bottom one is the one we want to use, it kind of shows us that surprisingly or kind of counterintuitively maybe even, the one at the bottom with a wedge actually provide a better or smaller focal area. So here, if we zoom on these, as we move, also the color is clear, but as we move, you always notice that the focal area on the top one, which is our contact techniques, is almost double the one on the bottom with the wedge. So as we move toward the bottom and even move toward the top, you kind of see that always seems like the technique with the wedge actually have a smaller focal area. So what this means is that with a new technique, we're actually creating a technique that is more focused or smaller, better focus quality. So with that logic, if the technique that had worse focusing or larger focal area could see that HTHA damage at an early stage, then logically the new technique should also have the same capability at least or same level of sensitivity to see those. So that was the justification based on BeamTool without using a cal block, simply only based on focal area map quality maps to move to this technique. And when we did the inspection, here you can see in the inspection result that we start to, on the actual vessel, we start to pick up these clouds of small indications close to the ID cladding, which was very close to what we would expect from early stage HTHA damage. And at this point now, these results are being assessed for fitness for service. I hope that this video was useful to you.